So on this website, I just showed you a bond market, that is the US Treasury bond market. And what you see is that yield curve is changing all the time, every second, every hour, every minute, every day. It is changing because market interest rates are determined in the market, and it is changing every second. And that's just one bond market. How many bond markets are there? Tons. You have US Treasury bond, you have GE bonds, you have Microsoft bonds, you have McDonald bonds. There are many, many bond markets out there, and we just saw one. What we want to learn from the observation of the yield curves are three facts that can be summarized by all the yield curves, tons of yield curves, millions, zillions of yield curves that we observe on the market. There are three general facts. The first fact is interest rate for different maturities in general moves together. If you see this graph, 20-year bonds, 3 months Treasury bills, 20-year Treasury bonds, 3 to 5 year US Treasury notes average. Those interest rates, as you can see, they are in general move together. What is the implication of this on the yield curve? If yield curve look like this is 3 months Treasury bill interest rates, 3-year Treasury notes interest rate, 20-year Treasury bond interest rates, and in general they move together. That is, when one goes up, the other one goes up, the other all go up. When one goes down, the others in general go down. So what does that mean? That means yield curve in general shifts up or down because they move together. So it shifts up. It is not like pivot up. No, this one will increase as well. Therefore, the first fact is yield curve in general shifts up and down because interest rate for different maturities in general moves together. The second fact is yield curve tend to have steep slope when short-term interest rates are low and downward slope when short-term interest rates are high. What does that mean? Let me rephrase this. The answer is when short-term interest rate, the one very close to zero, when short-term interest rate is very, very low, in general, yield curve is upward sloping. If the short-term interest rate is very, very high, in general, yield curve is downward sloping. That's what the second fact is saying. Let me say it again. When short-term interest rate is very, very low, in general, yield curve is upward sloping. Do you remember the yield curve that you see? When yield curve is upward sloping, usually it look like this, right? And when the short-term interest rate is very high, on the website, you see a flat or downward sloping yield curve. Remember that? If you don't remember, you can go back to see that website. That's the second fact of zillions of yield curves that we observe on the market over time. The third fact is yield curve is in general upward sloping. Remember on the graph, most of the time yield curve is upward sloping. So these are three facts that we can summarize from the observations of the yield curves on the market over time. The first one is yield curve in general shifts up and down. The second fact is when short-term interest rate is very, very low, in general yield curve is upward sloping. When short-term interest rate is very, very high, in general yield curve is downward sloping. The third fact is, in general, most of the time, yield curve is typically upward sloping. So these are the three facts that we generalized from the observations of zillions of yield curves over time. Now, we want to come up with a theory to explain these three facts. If we can find a theory that can explain these facts, then we can use the theory to predict the yield curve. That's what we want to do next. We are going to introduce three theories of term structure to try to explain the facts that we observe from the bond market. Okay, that is, we want to introduce three theories to explain why we see all those shapes of the yield curve. Remember what is yield curve? The variable on the x-axis is time to maturity. The variable on the y-axis is interest rates. What we want to know is why, when terms to maturity is 1, interest rate is this. Why, when terms to maturity is 2, interest rate is this. Why, when terms to maturity is 10, interest rate is this. So what is this interest rate? This interest rate is, at this moment, the 1-year bond interest rate right now. What is this interest rate? This interest rate is the 2-year bond interest rate right now on the market. And this one is the 10-year bond interest rate right now on the market. We want to know, where are those from? What theory can determine this? You know 1, you know 2, you know term to maturity 1, 2, 3. What you want to derive is this interest rate. Therefore, our goal is to find these interest rate. And to make examples simpler, I would like to introduce this notation. Before we go on, you have to understand what this notation is. So if I write I with 2 subscripts, the first one N, the second one is T. This N is the terms to maturity. And this T is the time that the bond is issued. Therefore, what is I1T? The answer is 1-year bond, the maturity is 1 year. 1-year bond interest rate at time T. Then what is I2T? It is 2-year bond interest rate at time T. Then what is I1T plus 1? I1T plus 1 is 1-year bond interest rate next period. Say for example, tomorrow. But there is a problem of this notation. Why? Do you know 1-year bond interest rate tomorrow? The answer is no, because that 1-year bond is not issued yet. Therefore, you don't know the 1-year bond interest rate tomorrow. Therefore, this notation doesn't make sense. Therefore, we want to add an E superscript. What does that mean? That means the expected 1-year bond next period. Let me do it again. So what is I 2t plus 1e? The answer is 2-year bond interest rate next year. You don't know that interest rate. Therefore, this is the expected 2-year bond interest rate next year. Okay, let me ask you a question. When is this bond issued? The answer is next year. When is this bond matured? The answer is T plus 3, because this is a 2-year bond issued at time T plus 1. Therefore, it is matured in T plus 3. Therefore, what is I n T plus 1? The answer is N-year bond interest rate next period, which we don't know. Therefore, we have to add an E superscript. So this interest rate is N-year bond interest rate, expected N-year bond interest rate next period. So you have to make sure that you understand this notation so that we can continue on introducing those 3 theories. First, we are going to talk about a theory called expectation theory. The result of that theory can explain fact number 1 and fact number 2. What is fact number 1? Yield curve in general shifts up and down, right? That is, interest rates on different maturities in general move together. What is fact number 2? When short-term interest rate is very low, in general yield curve is upward sloping. When short-term interest rate is very high, in general yield curve is downward sloping. But this theory cannot explain fact number 3. What is fact number 3? In general, yield curve is upward sloping. So this is not a correct theory because it cannot explain fact number 3. Then we introduce another theory that can explain fact number 3. But the problem is this theory cannot explain fact number 1 and 2. Therefore, this is not a correct theory either. So what can you do? The answer is we combine these 2 theories so that all 3 facts can be explained. That theory is called the liquidity premium theory. And this is the correct theory because it can explain all the 3 facts that we observed on the bond market, on the yield curves. So in the following, we are going to introduce one theory and the next, and then to find the correct theory. The first theory is called the expectation theory. Any theory is composed of assumptions. You make several assumptions and that becomes a theory. The key assumption of this expectation theory is bonds of different maturities are perfect substitutes. Now, have you ever heard about this term? Perfect substitutes? What does that mean? Yes, you have learned this in your microeconomics. In microeconomics, you have learned that, say for example, orange and grapefruit are perfect substitutes to you. What does that mean? Well, what is your purpose of eating orange and grapefruit? What's the purpose for you to eat orange or grapefruit? The answer is you eat orange to gain utility. You eat grapefruit to gain utility. That's the purpose of eating orange or grapefruit. If you are indifferent in eating orange or grapefruit, that is, eating orange or grapefruit will give you exactly the same utility, then we call that orange and grapefruit are perfect substitute to you. Let me say it again. If orange and grapefruit are perfect substitutes to you, then that means orange and grapefruit will give you exactly the same utility because the purpose for you to eat orange and grapefruit is to gain utility. That's the definition of perfect substitutes. Now, what does that mean by saying bonds of different maturities, different bonds are perfect substitutes? Well, what's the purpose for you to buy bonds? The answer is you buy bonds because you want to earn return. But in chapter 4, do you remember when you buy the bond, you know the interest rate, but do you know the return? The answer is no. When you buy the bond, you don't know the return. Therefore, what's the purpose for you to buy bonds? What determined whether you want to buy this bond or not? The answer is the expected return. Therefore, bonds of different maturities are perfect substitutes if these bonds give you exactly the same expected return. Then these bonds will be called perfect substitute to you. Now, let me give you a simple example. Bonds of different maturities. So that's consider two maturities. 1 year, maturity of 1 year, and maturity of 2 years. A very simple example. Okay? Now, you have two strategies. And your investment horizon is 2 periods. That is, you want to invest your money for 2 years. So you have two choices. Number 1, you buy a 1-year bond today, and then when the bond expires tomorrow, next year, then you use the money that you get to buy another 1-year bond. So 2-year investment horizon, you buy 2 1-year bonds consecutively. The second strategy is you just buy a 2-year bond and hold it for 2 years. Now, the expectation theory says bonds of different maturities are perfect substitutes. Therefore, these two strategies should give you exactly the same expected return. Now, let's look at the expected return from strategy number 1, that is, buy a 1-year bond today and then buy another 1-year bond next year. So when you buy a 1-year bond, if you invest $1, you buy a 1-year bond. What is the interest rate of that 1-year bond? The answer is, it is the interest rate, it is the 1-year bond interest rate that is issued today. So the interest rate of the bond that you buy today is I1T. Therefore, if you invest $1 today, next year, how much money are you going to have? The answer is 1 times 1 plus I1T. This is your principal, and this is the interest that you earn. Then at the end of the first year, this is the money that you have. Then you invest on another 1-year bond. Now, what is that 1-year bond interest rate? The answer is, it is a 1-year bond interest rate. But when it's issued, you're buying it next year. So it is the 1-year bond interest rate next year. But you are determining whether you want to use strategy number 1 or strategy number 2 today. Therefore, today, if you want to choose strategy number 1, do you know the 1-year bond interest rate next period? The answer is no, you don't know, because that bond is not issued yet. Therefore, the only thing you can do is to form an expectation. Therefore, if you buy another 1-year bond, you expect to earn this amount of interest rates. So at the end of the second year, you expect to get this amount of money. What is your initial investment? $1. So how much money do you earn? The total money you get minus your initial investment. Then what is your return, rate of return? The answer is, you earn this amount of money out of the 1 year at the $1 investment. Therefore, this is your expected return for strategy number 1. If you multiplied it out, distribution rule, this is what you get. 1 plus I1T, 1 times IE1T plus 1, plus this multiplied by this. Interest rate is usually like 3% or 2% or 1%. So that would say if it's 1%, that would be 0.01. And this one, say for example, is 0.02. Then you multiply it out, it is going to be a very small number. Therefore, we can ignore this term. It's very small. The result, this plus this minus 1, it is equal to this. Divided by 1, this is closer to the expected return of your strategy number 1. Now, what is your expected return from strategy number 2, which is to buy a 2-year bond today and hold it for 2 years? Okay, so again, you invest $1. What is the interest rate that you are going to earn from this bond? The answer is, you are buying a 2-year bond. Therefore, you are earning 2-year bond interest rate. When do you buy it? At time t. So this is your 2-year bond interest rate today. 1 year later, how much money would you have if you invest $1 initially? The answer is 1 times 1 plus I to t. This is the money you will have 1 year later. But you cannot get the money out. You earn another round of interest. And what is the interest rate that you are going to earn? The answer is it is still I to t because you hold that bond. You don't buy another bond. You're buying a 2-year bond. You're earning exactly the same interest rate. So another round of interest. This is the money you're going to get from the bond issuers 2 years from now. Minus your initial investment, this is the money you earn out of your initial investment. Therefore, this is your expected return for strategy number 2. Do the same thing. You multiply it out. And interest rate multiplied by itself, it's a very small number. Therefore, it's ignorable. Therefore, your expected return from the second strategy is very close to 2 times I to t. Now, expectation theory says expected return from the first strategy should be equal to the expected return from the second strategy. Because buying 1-year bond twice should give you exactly the same expected return as buying a 2-year bond. Same investment horizon, same holding period. Therefore, remember, expected return of the first strategy is I1t plus I1t plus 1e. Expected return from the second strategy is very close to 2 times I to t. Expectation theory says these two should be the same. And remember, what is our goal? Our goal is to find INT. How INT is determined on the yield curve. Where's INT? Well, you know I1t. Now INT is here, I to t. Therefore, what is I to t? I to t will be the average of these two. You divide both sides by 2. Cancel out. This is what you get. Therefore, expectation theory tells you that 2-year bond interest rate today should be equal to the average of 1-year bond interest rate today and expected 1-year bond interest rate tomorrow. That is, the expectation theory says 2-year bond interest rate today should be equal to the average of the next 2 1-year bond interest rates. If you don't like the equations, then I have a trick that you can use. We don't use equation, let's use blocks. Okay? So what you have to do is to draw this. So this is at time t. You have 2 strategies. The first strategy is to buy 2 one-year bonds. So you have 2 blocks here. This is time t, this is time t plus 1. So this is 1-year bond interest rate that you buy today. This is a 1-year bond that you buy today. What is the interest rate of that? It's a 1-year bond interest rate that you buy today. How about this one? How about this bond? This is a 1-year bond. When do you buy it? At t plus 1. But do you know the interest rate? No, you don't know the interest rate. Therefore, you have to form the expectation. The second strategy is you buy a 2-year bond today. So this is a 2-year bond that you buy today. What is the interest rate on this bond? The answer is it is a 2-year bond. And when do you buy it? Today. And the expectation theory says this interest rate is the average of these two. Therefore, use the same logic. Buying a 3-year bond should be equivalent to buying 3 1-year bonds consecutively. So this is t plus 1, this is t plus 2. That is, the first year you buy a 1-year bond. So this is 1-year bond interest rate. When do you buy it? Today. After you sell this 1-year bond, you get the money, you invest in another 1-year bond. So this is still a 1-year bond, same size as this one. What is the interest rate of this 1-year bond? The answer is it's a 1-year bond, but when is it issued? Next period. Do you know the interest rate when you are making decision today at time t? No. Therefore, you have to form your expectation. Same thing here. You buy another 1-year bond. When? T plus 2. The bond is issued here. When you are making the decision today, do you know this interest rate? No. Therefore, you form the expectation. So buying 3 consecutive 1-year bonds should give you exactly the same expected return of buying a 3-year bond, just one 3-year bond. That's what the expectation theory says. What is the interest rate on this 3-year bond? The answer is I3. When do you buy this 3-year bond? At time t. Therefore, expectation theory says the 3-year bond interest rate today should be equal to the average of these 3 1-year bond interest rate, I1T plus I1T plus 1E plus I1T plus 2E. Therefore, the same thing, 4-year bond interest rate should be equal to the average of the next 4 1-year bond interest rate, I1T, 1-year bond, T plus 1E, 1-year bond, issue at T plus 2, expected 1T plus 3E. Therefore, in general, the expectation theory says N-year bond interest rate should be equal to the average of the next N 1-year bond interest rate. Be very careful. This is N minus 1 because you have the first one here. So in words, interest rate on longer-term bonds should be equal to the average short-term bond rates expected to occur over the life of the long-term bonds. That is, N-year bond interest rate today should be equal to the average of the next N 1-year bond interest rates. And that's our goal, right? So expectation theory gives us INT. 1-year bond interest rate today, you know that. 2-year bond interest rate today should be equal to the average of the next 1-year bond interest rate expected. 3-year bond interest rate today should be equal to the average of the next 3 1-year bond interest rate expected. 4-year bond interest rate today should be equal to the average of the next 4 1-year bond interest rate. And so on. Now let me show you some examples. Keep in mind that we are talking about the first of the 3 theories, right? And the first theory is the expectation theory. And we know that the expectation theory is wrong. It is wrong, okay? It is not the correct theory. Therefore, the example here, we have to be based on this wrong theory. We assume that this theory is correct. So according to the expectation theory, if, listen carefully to my setup of the example, if the market expects the 1-year bond interest rate over the next 5 years are 5%, 6%, 7%, 8%, and 9% respectively. What does that mean? What is the notation of this 5%? The answer is this is the first 1-year bond interest rate. So it is 1-year bond interest rate today. What's the next 1-year bond interest rate? The answer is I1 T plus 1. But you don't know that today, so this is the expected. So what is this 7%? This is the expected 1-year bond interest rate 2 years from now. So 8% is the expected 1-year bond interest rate 3 years from now. 9% is the expected 1-year bond interest rate 4 years from now. So it is the fifth 1-year bond interest rates. The first question is, what is the interest rate on a 2-year bond? So what is the notation of the interest rate of a 2-year bond now? The answer is 2-year bond. When? Today. So the question is asking for 2-year bond interest rate today. You know that expectation theory tells you that 2-year bond interest rate today should be equal to the average of the next 2 1-year bond interest rate. So it's I1T and I1T plus 1E. Therefore, it is the average of the next 2 1-year bond interest rate, I1T, I1T plus 1E. So it's the average of 5% and 6%, which is 5%. So 5% is I2T. 5.5% is I2T. What is the interest rate for a 5-year bond today? What is the notation of that? The answer is 5-year bond interest rate today. which is the average of the next 5 one-year bond interest rate. What's the next 5 one-year bond interest rate? I1T, I1T plus 1E, I1T plus 2E, I1T plus 3E, I1T plus 4E. So it's the average of these 5. The answer is 7%. So by doing exactly the same thing, you can find the interest rate for 1 to 5 year bonds. So what is this I percent? 5%? It's I1T. What is this 5.5%? Interest rate for 2-year bond. That's exactly the first question we're asking here. So this is I2T. What is the interest rate for 3-year bond today? The answer is I3T is the average of the next 3 one-year bond interest rates. So it's the average of 5, 6, and 7, which is 6%. So what is this 6.5%? It is the I4T. What is this 7%? That's exactly here, I5T. Are you seeing an yield curve? A yield curve? The answer is yes. If the market expects the future one-year bond interest rate as this, expectation theory will give you an yield curve. Time to maturity. N. That is when N is 1, I1T is 5%. When N is 2, I2T is 5.5%. When N is 3, interest rate is 6%. When N is 4, interest rate is 6.5%. When term is 5, 5-year bond interest rate is 7%. So yield curve is upward sloping. So if this theory is correct and this is market's expectation, then currently you should observe this yield curve in the market.